Hello, AP Physics students. This is Mr. Evely talking to you the night before the absence. Unfortunately, I have to be at the ISD today learning some pretty important stuff. So tonight I am doing a quick lesson for you on video. This is going to be a short video, so fear not. Yesterday I did not get to one of our examples. Taught you a little bit about a technique we affectionately call the Siberian Husky technique. One of the types of problems that you see quite often is a type of train problem. So I've got several objects and 3 blocks here connected by short cables or chains, and the whole thing is being pulled along by a force. The force on block A is given as 255 newtons. They give us the mass of A, the mass of B, and the mass of C, and say there's no friction present. What they want is the tension in this little piece of cable, or chain, right there. All right, the technique, very similar to what we did yesterday, is to take a look at the entire system and then isolate one or more of the blocks to see if we can find the force in that chain. There's lots of ways to do it, but one kind of simple way to do it is to look at the entire system. The only force of consequence here is A, F of A. It says there's no friction. All normal forces are being canceled out by the weight, or vice versa. So we could say, look, the sum of forces on the entire system would be F of A, or mass total times the acceleration. So in other words, we can find the acceleration of the system by saying F of A divided by the total mass, or 255 newtons over 66 kilograms of mass. And we know therefore that the acceleration is 3.86 meters per second squared. Now, assuming these little bits of chain don't stretch or anything, we can say then that the acceleration of each piece must be 3.86 meters per second squared. Now, one way to solve this then is to isolate C and say, okay, what are the forces on C? We've got its normal force, we've got its weight force, which cancel out. We also have this tension force that we're after. And that tension force is responsible for accelerating block C. So, sum of forces equals MA. This force of tension equals the mass of block C times its acceleration. So we've got the mass of block C is given as 13 kilograms. We just calculated the acceleration as 3.86 meters per second squared. So that means we have a tension of 50 newtons. Okay. I don't know if you can hear the band practicing out there, but it sounds pretty weird. Now, that's not the only way we could go. We could isolate 2 blocks and say there's a force of FA this way and the same force of tension pulling backward. It should give us the same solution. It gives us some other solution, then it's inconsistent. And we know physics generally is pretty consistent. A second example comes from the textbook. We've got an example that involves an elevator. And I included this because these are not the favorite problem of all physics students. Generally, people don't like elevator problems. So if you take a look in the book on page 111, problem 42 is a lamp hanging inside of an elevator. So not something you see very often. And it says that the elevator has an acceleration. The elevator is heading downward and slowing down at a rate of 2.4 meters per second squared. So in physics, we know that that's an acceleration, not a deceleration. And if the direction of motion is that way while it slows down, in reality, that's an upward acceleration. Okay, so that's key to the entire problem. Okay, it also tells us that the tension in the cord that holds the lamp to the ceiling is 89 newtons. So I'm going to draw that in. Got our tension force. and this thing also has weight. Now, if I drew this well, I would end up with a force upward bigger than the force downward, since the acceleration's that way. And we go ahead and set it up. Now, the cool thing about elevator problems that a lot of people don't realize is you can ignore the elevator. What we're really after is the motion of the lamp. So we're just going to ignore the elevator and think about the lamp and say, okay, the equation of motion for the lamp is going to be Ft minus mg equals ma. And if you've read the problem is asking, what's the mass of the lamp? So check it out. We know this is 89. We know what g is. We know what the acceleration is. The only unknown is m. So we'll do a little rearrangement here. And this problem, too, is not a really tough one. Okay, so if we punch that through, we end up finding the mass of the thing, and I believe it's 7.3 kilograms, if I'm not mistaken. Now, that's just part A. Part B asks, okay, suppose that the elevator were heading upward while speeding up. What would be the tension in the rope holding the lamp to the ceiling? Now, you think about that. If this thing is heading upward and speeding up, the direction of the acceleration is exactly the same. F equals ma, all the equations are precisely the same. So it doesn't matter if it's heading upward and speeding up or heading downward and slowing down. The acceleration is still upward, 2.4 meters per second squared. The tension is going to be exactly the same. So in part B, we'd say tension 89 newtons. Okay? Our work is just the logic that nothing has changed. The direction of motion doesn't matter. In this case, it's the direction of the acceleration. All right. So I've approached the end of my first and short little video here. There's some things I'd like you to do in class. Together, I'd like you to do some problems in class. They are in Chapter 5, 13, 15, 21, 23, 26. Also, please do the questions. The questions appear just before the problems. They have to do with the reading. Do questions 1 through 3. So this is the in-class part of the assignment. The solutions for these guys are also on the Moodle page, you may have noticed. So you click on those, my PDF should show up with my work. Your work for this evening is the remainder of the problems of Chapter 5. Notice 42 we just did together. So you've got 5 problems and some questions. We can go over those probably Thursday when we see each other again and make sure that Chapter 5 is set. So thanks for watching. I will be back in a couple of days. Please take good care of the sub and take care of yourselves. I'll see you in a couple of days.